So let me go into the Python shell again now. So we have seen data structures, list structure, for loops. We've covered till for loops and range functions. Okay, now we have to look into while loops in depth. So there is something called break and continue. So I'm going to demonstrate those things when we are looking into while loops. Let's try using some library called datetime. So there is something called datetime library in Python. By default, it comes with Python. From this, we can actually extract the current date and do date manipulations. From datetime, I'm going to import datetime. Let's just see what this datetime gives. Datetime has a function called now, which gives us the current date in the datetime format. We can actually find out the number of seconds, number of hours, the current hour, current minute, current second, and everything. So let's try to get the seconds, and let's try adding some number to it. Say I'll add 4 seconds to it. The current seconds plus 4, 8. So if I just print current seconds, 4. So by the time I issued this, there are 2 seconds have been passed. So what if there was a second time which comes around 60 or 56 or 57? Now if I added 57 plus 4, it becomes 61. So but I need to make sure that second time, seconds is like after 60, it will come from 1, right? Again. For that, I need to use something called the modulo operator we have seen earlier. Let's just see. Modulo 60. So if it is 61, 61 divided by 60 will give us 1 as a reminder. So that means it will become 1. Now this time, this works for the current second. What is the current second number? Let's use this in a while loop. For now, let's just say, so I'll create a while loop that will wait for like 4 seconds before coming out of the loop. So let's write a while loop now. Datetime now. Seconds. Not equal to the seconds. Same thing. I'm going to copy. I'm just going to wait for 4 seconds. This loop will wait for 4 seconds. So this statement, if I use it here, it will loop forever. So, but before that, I should write things like this. Let's say I'll add for 10 seconds here. This will be the like end time, end seconds. The current seconds, number of seconds plus 10 seconds is what the interval I want to run. So I'll write a while loop, date time, but now, but second, while it is not equal to the current 10 seconds, which means 4 seconds or 10 seconds past the current second, it will keep waiting. Let's say I'll print waiting. This thing may not run right now because we have done it keeps on running till it becomes 10 again. If we see while doing this, if I print the second interval, date time dot now dot second, and then I print waiting. Let's see what it prints. 37, 38, 39, 40. It's waiting till that 10 seconds. The loop is running for 10 seconds. The start time was almost 36. So in that, every second, it is actually iterating so many times. That fast the code runs. So this while loop is running in a second this many times. If you see the output here. So that's the speed at which our processor works. So let's say I'll just not print anything and break out of the loop only when the end seconds has moved. I'll just remove this and put a pass statement. Pass actually means nothing. So instead of printing, I can just do one, let's say something like 1 plus 1. It's not a problem, but unnecessarily we'll be calculating things. Yeah, we'll be wasting processor time. So I'll just do a pass statement here, which means no calculation, do nothing. So it waits. If you see this, prompt is not coming. The while loop is still running. This condition is true. Once this becomes true, then it will come out of the loop and comes here. A prompt comes. In another terminal, I can open and see what's the current time. Right? From date time to report. Date time up now. Second. It's 53. Okay, now it came out. So let's write this logic in a different way. I'll say while true. So while true actually means this is an infinite loop. Unless we break out of this loop, the code will not come automatically out of this loop. It keeps on printing something. Let's say I'll just do a print statement here. Something. Great. Or I'll not do any break. This code runs forever. Keeps on printing and it uses up all the CPU that we have. So I'm going to cancel that now. Cancel it. So this is how we create an infinite loop, but most of the times we will not. It's very dangerous to create this kind of loops. While true, I'm going to write. So if I just say break here, this code runs only once. Print high and then break. This code runs and the statement will break out of this loop. It just prints once. This loop runs only once. As soon as the interpreter sees the break statement, it will break out of the immediate loop that is in. So let's write our logic of waiting for the seconds to pass until wait time. If date time dot now dot second is equal to wait time, then break out of the loop. Otherwise, just stay in the loop and not print anything. Wait time. Wait time is okay. This is end time. What did we define it as? Let's define end time one more time. Okay, end seconds is what we defined it as. 10 seconds. This loop will run till that time. It's still running. Let's go check the second now. 33. So as soon as this condition becomes true, the break statement gets executed. Break actually means come out of this loop. See what's the time? Yeah, it came out of the loop as soon as this seconds interval became equal to the n seconds. So that's the demonstration of break statement. There is something called continue statement. For the same purpose, I'm going to use a simple calculation here. Let's just add a counter here. Instead of using this seconds and break, we'll add a simple counter. Count. I'll initialize a value count as 0 while true. Count plus count equals count plus 1. So one more optimization we can do here is instead of writing like this, we can actually write it like this: count plus equal to 1. This actually means count is equal to count plus 1. This is a shorthand for writing count plus 1 for count. Now, if count equals 5, or if count is divisible by 2, then continue. Don't print even numbers. This means don't print even numbers. Continue means it will skip whatever lines that we write after this statement and iterates with the next loop, next iteration. Let's try printing n here, count here. Now, if this condition is met, the continue statements get executed, and which means that don't continue doing the below statements, just skip them and start from the first line iteration, next iteration. Let's try running this and let's break out of this loop. If count is greater than 100, break. So it goes till 100 and then breaks out of the loop. Now, if we see, it printed only odd numbers because we skipped printing even numbers with the continue statement. Yeah, this is how continue works. Then now we will come back and look at the for loops in depth. Let's say I have a list, my list 1, 2, 3, 4. For item in my list, print item. This we all know how this works. Let's try doing something similar with a dictionary. I'm initializing this dictionary with a as an array. Antelope B to bear, C to cat, D to dog. So this is a dictionary.
Sir,
Now I'm going to write a first statement that iterates through this and does nothing. For
hello.
letter, an animal, lookup, just do nothing. We have seen past statement earlier. This time, sorry. Actually, we should use, if I'm using a dictionary, I need to use dot items. Dictionary is not an iterable or extractable like this. Only the items will be written as, yeah, once. Yeah, it's array and list are same. My list, if I'm array and list are same. List. I mean, what I meant by array is list. List actually, it's analogous to C language arrays. So in C language, we call them as arrays. In Python, we call them lists. Somewhat similar, but not same. So if I see an animal lookup, this is a dictionary. So array definition is like a list of similar data types, but in Python, it's not strictly necessary to have same set of data types in an array. It's an array is an iterable object, a list of things. Array or list is interchangeable. I'm calling array itself as list in Python. So when you see C and Java, arrays are different. There is list is a different data structure in Java. C arrays are same data types we should use in if I'm using integer data types in the array, all the elements in an array should be integers in C language. When it comes to Python, we can have any type of element in the list. List is an iterable object. We can iterate through each item. So coming back to the animal lookup. So if I want to print the list of items, I can just iterate through these things. Letter, comma, animals in animal lookup dot items. This items gives the list of tuples. If I just remove this and try printing animal lookup dot items, it gives a list of tuples with first element as the letter and second element as the list. So that is what I'm going to use in a for loop now. For letter, for each letter, I have a list of animals in animal lookup dot items. So I'm going to do some check here. If length of animals is greater than 1, continue. So this actually means for any letter which has more than one animal in it in its list of values, don't print that animal or letter. If not, print the animal letter and the value. This we have seen earlier. I'll explain one more time. This print statement uses an F string. So F strings can use any Python variable or function inside this curly brackets. When I'm accessing letter, it actually replaces the value, the statement, this entire string will be replaced by the letter value. Even this will print like this. Let's see how this looks. So it's printing B, C, and D, but it is skipping A because the length of animals list is more than one. This is conditional logic within a loop. So we have seen break statement here. Sorry, the continuous statement here. Let's see the break statement. So on the same loop, if the count, if I just want to extract only two items, it can be in any order. So I'm going to initialize a count value, count as 0. Every time I iterate through this, I'm going to increment counter by 1. So this is the first element. If count is greater than 2, break out of the loop. This actually means only extract the first two elements or like any two elements from the animals list, animals dictionary. Let's try that. So it has given A and B. Only two elements it gave us. Any doubts so far? Okay. There is a special scenario called for else loop. So let's try creating a new loop for number in range 2, 100. We have seen range functions. It gives a list of numbers starting from 2 and ending at 99, excluding this 100. Let's try to find if any of these are prime numbers. Let's say we have to find out if this number has any factors that are exactly divisible, that are dividing these exactly. Per factor in range, actually in order to find the prime number, we have to, if a number is prime or not, we have to find out all the factors that are below its square root, whether they are dividing this exactly or not. So the same logic, I'm going to write it here, starting from 2 till the numbers root, square root. Okay, before going into this loop, let's try to find out the square root of a number. Let's say I have number 4, number is equal to 4. How do I find out square root of this number? So square root of the number is nothing but power. The power is 1 by 2, half of its power. Let's say 4 square is 16. 4 in raised to the power of 0.5, which is 1 divided by 2, same as 0.5. This gives me the square root of this number. 2 is the square root of this number. Similarly, 3 square root, if I want to find out, this is what it is. Square root of 2 is this. So now I have to find out, I'll just wrap this up into an integer, 2 power 0.5, sorry, 2 power 0.5 is 1.414. Okay, so now I'll just wrap this into an integer, say 4 only, square root of 4 is 2. So that I'm going to use in this logic. So now for number in range 2, 0, 100. 0, we know that this is all prime numbers start from 2, range till 100. For factor in range 2 comma the maximum range should be number into 0 power 0.5. This should be converted into an integer because it gives a floating point number. Any division or power operation will give a floating point number because we are actually raising to the power of float, which is 0.5. Now this gives me all the prime factors that are between 2 and to this number, square root of the number. Let's say 4, we have iterated till 4. It gives the number starting from 2 till 2, or like if it is 9, 2 to 3 it will give. But it won't include 3 here because the range function does not include the last element. If I'm saying 2 to 100, it gives only till 99. So this thing will get excluded. So that's why I need to add one more element to it, one greater than the square root of this number. This means it goes till from 2 till the square root of that number, which I'm evaluating whether it is a prime number or not. If I want to check if this number is prime or not, so I need to verify if this factor is dividing this by exactly or not. If the remainder when I divide the number by this factor is 0 or not. If it is divided by this, then it is a prime number. When let's just print this is number is prime number. Number is a prime number. Sorry, is not a prime number. Sorry. If none of the factors can divide this number by divide the number exactly, then it is a prime number. If it is divisible by the factor, then it is not a prime number. See, we can see that we are actually finding all the numbers that are not prime numbers. So remaining ones are the prime numbers. Let's try doing this then. Now, if I want to negate this logic, I just want to say like I'll initialize a value called is prime equals false. Okay, is prime is I'll just initialize it to true, and is prime equals false. Great. And here, if is prime, print number. This gives the list of prime numbers till 100. This is fine. So there is one more better way to write this logic. So that's what I'm going to demonstrate here. So instead of writing like this, I can just remove this, and even this I can remove. I'll just write one thing and then I'll explain. Print number. So what this means, else, for else, this is called the for else loop. So if this for happened without any break, this code runs. If the for loop runs without any break, if all the things are run without any break, then this else condition will run. If for loop is breaking out of this loop, the else condition will not run. So actually means if number is divisible by the factor, then it breaks, right? It's breaking means this else condition will not run. So the number will not be printed. If this continues and it did not go into this break statement, and this else condition runs. Let's try running that and see how it looks. 2, 3, 5, 7. It's giving the correct prime numbers. This is an advanced way to write for else loops. So if for loop runs without any breaks, the else runs. If the for loop breaks for some condition, then this will not run. Either do this or do this is what it is. So if this thing did satisfy a condition and break out of the loop, then this particular statements will not get executed. That is for else statements, for else loops. And that's about the for loops. Let's now take a look at functions. So we have already seen functions. Let's go a little bit deeper into functions. Let me define a function. The definition of a function starts with def, and let's say I will write from perform some operation. Functions usually are used for reusable code. Every time if I want to write some similar logic, I don't have to repeat the code, and I can write that code in a specific function and then call that function with variable arguments so that I don't have to repeat the code in writing. So let's say I will define a function that does some operation, either a sum operation or multiply operation. Perform an operation on number one and number two. And I will also specify the operation as a optional parameter, as a parameter. Yeah. If operation is equal to sum, then return number one plus number two. If operation is equal to multiply, return number one multiplied by number two. And how do I call this function? Is through perform operation of number three and number four. I will add sum as the argument, sum of 3 and 4, and multiply as another call. Okay, this is default definition how we write a function. So there are things that we can do if I want to say what is the default operation that I need to perform, even if somebody is not giving that operation itself in the arguments while calling the function. Let's redefine this with a default argument. So in the operation, I'm going to define the default operation as sum. If somebody is calling this function without providing the third operation parameter or argument, by default, it does summation operation. So let's do 3, 4 and skip the operation field itself. So perform operation. Perform, yeah. Perform operation 3 and 4. It's by default doing a sum operation, returning this statement. I can also specify this statement. I can, if I provide operation as multiply, it does multiply operation. And now, what if I want to have one more argument? Let's define this to have one more argument. The significance of it, I will explain. Message equals some message. And I'm going to print that message here. Message. Print. Sorry. I'm going to call the multiply operation. It's printing some message. Okay. Now I want to customize the message also. I can pass it another message like this. So this is one way to call this function. So there is another way, explicitly mentioning the parameter name also. Let's say message, sorry, operation is equal to multiply and message is equal to another message. Okay, so good. So what if I switch these things? Another operation. If I want to change the order, I can do that when I'm specifying the operand argument name. I can actually switch these, or in any order I can pass, as long as I'm giving the correct argument name. I can pass the message in any order. So message, I can pass it as reordered message. So usually num1 will be 3, num2 will be 4, because I'm passing these as keywordless arguments. This is the keyword arguments, which means there is a name to it and a default value assigned to it. If I define it like this, I can pass it in any order I want. This is for like long functions which have multiple keyword arguments. It doesn't matter which order you pass it in, as long as you are passing in the name of the argument and the value of the argument like this. Now, if I call this function, it does the same thing. So order does not matter. When we are not specifying the default keyword and value, then the order matters. So we have to pass the arguments in the same order that they are defined. So let's say now I have a function. Let's define a function that has multiple arguments, or a perform operation of arguments. I'm just giving a name as arguments and just print arguments. So if I just want to pass multiple parameters, 1, 2, 3, 4, 5, doesn't allow. So there is one way to handle this. Instead of args, if I define this as star args, this means this function can accept any number of arguments. Let's try running that now. Perform operation with 1, 2, 3, 4, 5. Like 5, it can be like 6, 7, and any number you can pass. That all those things will become a tuple in the args object. So there is one more similar to this about the keyword arguments. How do I pass keyword arguments? That is through kw args. If I define star kw args, I'll just print kw args also here. Let's try calling this. Okay, kw args is empty because these are named. Kw args will receive named parameters. Let's try giving names. My argument 1, named argument 1. Oops, I arg 2, something else. For now, call this function, and this named arguments will become a dictionary. Kw args will receive a list of a dictionary of named arguments as key value class. Each key of the named argument key will come as the key, and the value will come as the value. So this is how we pass multiple unknown number of arguments and unknown number of named parameters. Any number of named parameters we can pass, and if it is found in kw we can do some operation. So let's rewrite our mathematical calculation logic with this star args method. It can accept any number and it will sum all that up. If it is multiply, it will do a product of all that. So for that, I'll just import math library. This math.rod accepts a list of numbers, and it will give me the product of all those numbers. So those two arguments. Okay. So if you need help, we can list the help of math library. You can see all the functions it supports. So I have seen earlier prod, iterable object, and it accepts list also. So if you pass it as a list, it will work. So earlier I was passing it as numbers. I should now pass it as list of numbers. It gives me the product of all the numbers that have been passed in that list. Okay, nice. Let's use that math function. Math. So let's define a function called perform operation, and I'll define arguments. I'll define operation as sum as a default. If operation is equal to sum, there is a uh, default function in Python which is available on the global scope, which is called sum function. I can perform this sum function on these arguments. If operation is multiply, I can make use of the math library, return math dot prod of args. Args is already a tuple or a list, so that's going to be fine. Let's do a perform operation on list of arguments 1, 2, 3, 4. And operation, I'm going to give sum. Yeah, this is working correctly. And then if I just change this to multiply, let's run this, and it gives me the right answer. All right. Okay. So now we have to look into the scope of these functions. So there are args and KWRs we have defined earlier. And now let's rewrite that code, perform operation like args and KWRs. KWRs will have to have 2 stars. 2 stars means it's a dictionary. 1 star means it's a list. Print args, print args. So while doing this, let's also print the locals. Print, there is something called locals function, which gives all the local variables of this particular function. Within this scope of this function, what are all the variables available to it? And let's do that, call that operation, perform operation, increment to sum. And local variables, locals is getting printed like this. So arguments is available, KWRs is available to it. So all the local variables within this scope are printed. Now there is something called globals also, which prints all the available variables and values in the entire context of this program. Let's try running that. And these many are there. So there are default global values which will be used in the future. So the name of the file that it shows, main function, it's actually, the name is main here. So in usual scenarios, when we are writing code in text editors, we define functions like this, and then we will use something like if underscore underscore name equals main, call some function. This is mostly used in production. So when we define all the functions like this and then call the functions if this file is being run as a main function. So this will go in depth into later. So just to know the global context, what all variables will be available in global context, we can print globals, we can call globals method or function, and we can see all this. Let's see if this has any function definitions. And this has source files and everything. So there is a way to get the source of the current file that we are running also. So we'll go into that in a few minutes. And let's define a global value. Let's say I have a message. This is defined globally in the entire Python context. Some global value message. And I'm going to define a function or I'll define a variable A with value 2. This is all defined globally, not within a function. Let's go define a function called function1, variable A, variable B, and this var A and this var A are different. I'll demonstrate that now. So I'll define another message here within this function, some local data. This message and this message are different. So this is globally defined and this is defined within this function, and this is also, these two also are within this function. The scope of it, I'm going to demonstrate which one is available where. If I print var A and print message and then print locals, this gives a list. I'm going to call that in a few minutes. Let's define another function called function2 with variable C and variable P. And print var A here, which is not defined locally. This var A is actually going to be this value. I'll show you in a few minutes. Let's print message also. It's not written, that message is not defined here in this function. So this is going to access this message. And let's print locals. Now let's call function 1. Sorry. Function 1 with arguments 1, 2. So it has printed var A, which is variable A is 1, message is some local data, this message, not this message. This message has overridden this scope. So while this variable is found within this scope, it won't go access the global scope. If the function does not have that value, then it will access the global scope. If there is something locally defined, it will use the local variable itself. So if I see the locals here, var A is defined, var B is defined, and message is defined. Var A, var B, and message. If I do the same thing with function 2, I'm going to pass 1 and 2, same values, while this accessed var A is not defined in this scope. Only var B and var C is defined. So if you see here, var C is local. If you see, this statement has printed this. Var C is available, var B is available, which is 1 and 2 respectively. And message is not defined locally. It is actually available from the global definition of this message. So it's accessing the message from here, not from anywhere else. So if there was a message defined over here like this, it would have accessed the message from here. And var A is not defined within this function, so it tries to access from the global scope, which is value is 2. So that's how the scope works. Is that clear?
Yes, sir.
Sir, once again explain, sir.
Okay. So function one, I'm defining a value called message and where a as 2. If I define a function, let's remove all the statements. Let's try printing message here. Function one and comma 2 I'm passing. And this prints message from global scope. Let's try redefining the function with some message over here. Same variable name I'm going to use and some other message I'm going to use. This is local message. Okay, now call function one with 1 comma 2. Function I defined and I did not print it. So define this and print message. Let's call the function 1 comma 2. So this actually printed the message from here. It did not access the message object from here. It is which is globally defined. So if a variable is defined within a function, it will access that variable itself. It won't access the global variable. Understood?
Yes, sir.
Yeah. And there is something called globals function, which gives us the entire global context of this Python script. The entire shell has these values in it, default values. And if inside a function, if I do locals, print a locals, print locals, it gives all the local values, local variables. When calling that function, local variables are these. Var A and var B are local variables. So let's demonstrate that even further. Now let's define a new function. Function one, same thing, var A, var B. And message I'm defining as some local message. And print of var A. And I'm defining another function within this function. It's possible to have nested functions also. I'm defining another function called inner function, like this. It accepts var A, var B. This var A and this var A are different. It's not the same. This is to demonstrate the preference of the scope. So which will be preferred? If I just print something here, some f string values, inner function gives me within the inner function scope, the values are like this, locals. And out of this, print locals. So this local statement is not part of the inner function. This is part of the function one. So based on the indentation level, this scope changes. So I'll call inner function from here. So this doesn't get called unless we call this function. When we call this function, this goes through these statements and defines this function in the runtime and calls that function at the end. Let's try running that. Function 1 comma 2. And here we forgot to call the function with arguments. So we have to give some set of arguments to var A and var B here. That was a mistake. 1, 2, 3, 4, 5, 6. I'm going to use. Let's run this function. And when we are seeing here in the function one context, in the inner function context, this is the statement. In the print locals in function one, this is what it had. So if you see here, var A is defined, var B is defined, message is defined, inner function is also defined. So inner function also is a variable for function one's locals. If I see locals, it includes both variables and functions defined in that scope. This gives us a concept now. The variables can also be a function. Let's do that in a few minutes. Let's look into this logic in a few minutes, but the scope, if we understand better, then it's easier in the future. So if I try to run this inner function here, 1, 2, 3, 4, 5, 6, I cannot run it because the scope of it is defined within this function. So this function, inner function, is available only to the code that is written within this function, not outside of this function. So the scope of this thing is not visible outside of this function because we have written the definition of it within this function. So now let's look at this specific statement. So why is this inner function coming as a variable within this locals object? Let's see this. Now I have a variable called x equal to 5. I can also have 5. I can have a function defined, but it need not have a specific name to it. That we will do next. Let's say I define a function called x that says return 5. X, if I call, this gives 5. That's good. Can I store this function in a value or a variable? We can. If I say something like, let's define some set of functions here. Def function 1. For demonstrating that, I'll just show you a list of functions you can write. Print 1. Def function 2. That prints 2. Function 3. Prints 3. Now I can have a variable list of functions equals an array. I can have function 1, function 2, function 3. What I just did is I'm just adding all these functions into an array. So this list, sorry, array or list, this is a list. So if I just print list of functions, this is a list. So this is actually assigning the value. This value is the address of this function. We will go in depth into addresses and references later, but just this representation gives us the list of function addresses. If I want to call these functions one by one, I can just iterate through this list of functions for func in list of functions. This is just a name I've given to the value. This can be I, R, A, R, B, or C. This F, R, A, B, C, anything it can be. For each function in list of functions, I'm going to call that function like this. Let's see. It's printing, it's calling function 1, function 2, and function 3, which is in turn performing these print operations of 1, 2, 1, 3. This is how we can store functions also into variables. Let's say I define a function. I'll define some function, print this is text. Now I can store that function in a value, in a variable like this, x equal to some function. Now if I call x, it's going to call that function. If I call some function, it's going to call that function. So what I'm doing here is I'm just assigning the reference of this function. By default, the function's reference will be stored in its function name. So what I'm doing here by assigning some function to x is the reference to this function I'm assigning to x, which is equivalent to assigning the same address to x. So if let's say I'm defining a variable called y equals 5. So this actually is storing value 5 in some address in memory and assigning that address into y. So if I'm trying to print y, so what the interpreter is doing is it's reading the address of y and reading the data from that particular address. If address of y was like 1002 or 1003 in memory locations, so it's reading from that location and printing it. If I do x equal to function 1, what this is doing is the address of function 1 I'm assigning to x. If I'm doing x operation, what interpreter is doing is it's extracting the address and extracting the code within that address and running that code here. Okay. So the variables can also have functions referring to it. So there is a simple another way to define functions. Traditionally we do with function 1 and comma 2 comma sorry variable v1 v2 and v1. We do it like this, right? So there is another way to define functions in a shorthand operation. If it accepts only specific arguments and returns only one value, we can do it like using lambda functions. So we are defining always a name to a function. We now need not define a name. So this is the format to define a function on the fly. Something called lambda functions. This is called lambda functions, the definition of which I'm going to demonstrate now. So it should start with lambda and some number of arguments. So I'm going to use x as a, or like v1, v2 as arguments, and colon v1 plus v2. So this is the result, return value, and this is the list of arguments. Let's try running this. We should put the brackets in it. Sorry. X colon missing two required position arguments. Let's define that like this. Lambda, I'm defining lambda x returns x plus 1 into 4. Okay, the problem was this. Okay, I defined a function called lambda. I'm giving value 1, value 2, and returning value 1, sorry, value 1 plus value 2. And I'm calling this function, but not providing the values for v1 and v2. That's the reason it failed. So let's pass something 1, 2, 3, 4, 5, 6. Perhaps we forgot a comma. Okay, I think we should put brackets here. Let's syntax AMBDA. Sorry, there was a spelling error. Let's try running this like this. Okay, now it works. So the way to define it is LAMPDA and the list of arguments that we want to pass to the function, an equivalent of def function 1, v1, v2, return v1 plus v2. The same function, I can define it like this: lambda, 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 v1 comma v2, colon, v1 plus v2. This can only have one statement in it. We cannot have multiple statements, only one statement here, but which is the return value. So in order to call this lambda function, I can call it like this. And with values 1, comma 2. The arguments v1 and v2 should be passed like this. And this gives me 1 plus 2. So here, actually what I'm doing, I'm defining the function on the fly and calling that function on the fly in one statement. Instead of writing a definition again and then calling that definition of the function, I'm writing a lambda function, which is one line of code to do simple operations. These are called lambda functions. And now let's look into classes. So we have seen the dog class earlier. Now we'll look into the inheritance of classes. Classes can have subclasses. Let's define the dog class that we had seen earlier. Def init. Init is a constructor which accepts self as a default argument. First argument in a function, in a class function, should have self in it. Self means the reference to the current object it's going to pass every time. So I'm defining a name, giving a name, and I'll assign self.name as name, self.legs 4, and I'm going to define another method within it called speak, which also accepts self. These are called instance methods. So there are static methods also available. I'll go into that in a few minutes. What is static methods and what is instance methods? These are actually instance methods. These instance methods will always have self variable as the first argument. And this one, let's print self.name says dog. So let's define a dog object like this. I'm going to give the name as Rex dog dot speak. Okay, now we have a dog object. So we have seen the instance variables here. Let's define the same thing with static variables. What do we mean by static variables? So if a specific property belongs to an instance of the class, so the name actually belongs to a specific dog. It's not in general, not all dogs will have the same name, but usually all dogs will have 4 legs. Those kind of properties we can put under the class as a static variable rather than as a dynamic instance variable. So I'll just remove this legs from the stack instance variables list. Remove from here and add it over here. Legs as 4. So by default, all dogs will have 4 legs. That's what this means. Now, same thing I can do dog of Rex. Dog.legs, if I try to access, gives 4. So in the earlier scenario also the same thing happened, but it was accessing an instance variable. Let's just try to see, create one more dog item. Dog, new dog, dog of new dog. Now let's try to manipulate the legs object over here. legs to 3 I will make. Let's try dog dot legs. But still the dog dot legs is 4. When I did through this new dog object, it only changed the instance variable of it and not the static variable of it. So when I'm defining legs here, it's a static variable. If I access the variable with class name, it will always access the static variables defined over here. If I access with the instance name, instance object, it will access the instance variables. So new dog dot name, if I do, this is new dog dot name, if I access, this will give me the rex, which is this. And if I try to do the same thing with dog, if I do, so as I've changed new dog dot legs here, let's try changing the class legs. Dog dot legs is equal to 6. Here I'm actually manipulating the static variable within this class, which means it's globally for all the dogs. Now let's say if I change or create a new dog, third dog, dog 3, and create a dog object with name as AA, and dog 3 dot legs, if I try to access, it gives 6 because we have changed the global static value of this dog class. The global property of this dog is that it has 4 legs. Now we have changed that property to have 6 legs. Now, by default, all dogs will have 6 legs. That's the kind of logic how it is. So the global values defined within the class will take preference if there is no local instance values specified. Similarly, if I have, let's say, this object is there and I'm creating my dog, this dog as Rex, my dog dot legs, if I access, I haven't changed anything over here now. It still has 4 legs. Now, if I set the legs to 4 or 5, if I now access my dot legs, it gives 5 because it's an instance variable. We haven't changed the class static values. This actually means when I'm trying to do this way, what it actually means is it's like assigning self dot legs equals 5. That's what it is doing. When I'm changing the value with the instance object, it changes only for that particular instance, not for the entire class. When I'm doing it with the class name, it does for the entire class. Whenever new objects get created from this dog class, all those objects will have default legs as 6. So that's the difference between accessing values from instance objects versus accessing values from the class objects. So this is kind of a dangerous operation. Like default properties, nobody should be able to touch these default properties. So a convention in Python is to define values that are not modifiable as starting with underscore. This is only a guideline, but the users can actually change these or override these. So this actually means that nobody should change legs value directly. So they can do operations on instances, but not on class variables. So now if I want to give them a wrapper function to access this value, let's define another function, get legs. This I can do it with an instance, do it as an instance function. And this can access self dot return self dot underscore legs. This is perfectly valid. Now, if I define a dog, dot get legs, it gives me 4. Fine. Now, let's define one more class to demonstrate static methods. Now we have seen only the instance methods which accept self in it, but we haven't seen static methods yet. So let's define a class which has static methods in it. Let's write a class called word set, which has constructor initialization, which accepts self as a default argument. Any constructor, or this is called a constructor. Init function is a constructor for every class. So I have defined an instance variable called words. Within that instance, self.words, I'm defining it as a set. Set by default has empty set. And sorry, I'll define another function. So definitely add text to the word set, which accepts self as a default argument, first argument, and also one more thing, text on one pass. This does something like text equals self dot clean text. So clean text is not defined yet. I'm going to define that in a few minutes. And after the cleaning of the text, for each word in the text, we have already seen this. For word in text dot split, split by default splits a sentence by spaces. If each word will, if there is a space, it will divide the sentence by space. So all the words will be coming as a list if I do text dot split on a sentence. Let's do self dot words dot add of word. So this add function is a default property or a default provision of the set data type. So words is a set data structure. We can call add function to add a specific word to that particular set. That's what we are doing here. Now let's define another function which we have defined here, called here clean text, which removes all punctuation and everything. This is also a instance function. That's why we are passing self to it. And then let's do text replace. Replace all the punctuation characters, exclamations by empty strings, and then replace. This is called chaining of functions. We can call functions on this. Returns a text object which removes the exclamations, and then on top of it we are calling one more replace. Replace all the dots with empty strings, and then replace all the things starting with the comma, empty strings. Yeah, that should be enough for now. After doing that, return text dot lower. So I'm done placing all the letters into small letters. That's about this function. Let's try running this. Create a word set object. It's an instance of word set. I'm going to call word set dot add text. Hello world. This is some sample text. Let's try printing word set and words. Okay, this gives me all the list of words. So the thing here is this add text has to have instance variable self because it's accessing self.words. And this clean text is a generic function. It doesn't access any of the values or variables or methods from this self function. Now we can make this thing as a class method rather than an instance method. Let's redefine this class and remove the self value from this. Now, this is a static method. This is a class method or a static method. Both are one and the same. And whichever function has self as an argument is an instance method. So we can call this method only on instances, while this method can be called only on class objects. Now let's try running this and see if there is an error. So we are trying to access this clean text method with the self context, which is on the self instance value, instance variable. Let's try running this with create a new word set and then add same text. Now if I do the add text, it's trying to call clean text, takes one positional argument, but two were given. When we were trying to access legs from the self instance value, it did not fail. When we are calling the static methods with the self instance value, instance variable, it will throw this error. So for that, we need to replace this with the class object itself. Word set. Instead of self, I'm going to use word set. This is how we call class methods. Class methods or static methods of a class. This is the class method. Let's try doing this one more time. This time with word set. Then add text. It works. Now print word set dot words. Now this works. So all the utility methods can be made as class methods or static methods. So any method which doesn't have self as a first argument is a class method and can only be accessed with the class name, not with the instance name. So if I try to do clean text on an instance, let's say word set or clean text of this text, this doesn't work. When I do the same thing with the capital W word set actually is the class name. This will work. This gives me the clean text. So any class method or static method can be accessed only with the class name. That's what we have to know from here. And that's about classes. And one small concept we are going to introduce here. Classes can inherit from parent classes. This is a very important concept in object-oriented programming. Now we have seen dog class. Let's go redefine dog class. Here we have a class, dog class. Redefined it now. So let's say I want to have a small dog which doesn't bark. So I can extend from that same class and I can define a class called small dog. And I can inherit all the properties, all the methods from dog class. The way to do that is through this way. Small dog, it extends dog. And I'm not going to write anything over here for now. I'm just going to put pass, which means do nothing. Now I'm going to define a small dog. Small dog equals small dog. This is called inheritance. Name it should accept. It's trying to call init object, init function with a name. So I'm going to give a name as my small dog. Call that. Now st dot get legs gives me 4. St dot speak says my small dog says bark. Okay, now, so I don't want the small dog to bark, and I want this to say like I can't bark. Let's define override the functions. Instead of defining small dog with pass, I'm going to override the definition of speak over here. Self, and then print self dot name plus says I cannot bark. And that's the only method I'm going to override. So now if I initialize an object, small dog equals small dog. I'm giving a name as small dog. And if I call small dog dot speak, gives me small dog says I cannot bark. And if I try to access one more method, get legs on this small dog, it gives 4. This method is getting, this small dog is getting this method from the parent class, which is dog class. So all the properties and functions, methods of the parent class will be inherited by the small dog, which is a subclass of this. This is called a subclass. When I'm inheriting from a parent class, this becomes a subclass of this parent class. So all the properties, attributes, methods will be inherited in the small dog. And if I want to override a specific functionality, I can override only that specific functionality over here. That is what we have done here. This is about inheritance. We'll go in depth into object-oriented programming, extending the built-in classes and everything in the later classes.